So this is called the rational root theorem, and it's got a big fancy name. But let me explain why you would care, when you would use it. Excuse me. Thank you. All right, stay focused. So this has a 4-term polynomial. It does not factor by grouping. And you're not sure what roots could possibly even work. Like normally they just tell you what roots work. Yes?
Why doesn't it factor by grouping?
Because I didn't on purpose set it up to factor by grouping. Sometimes they do, sometimes they don't. Just like I will submit this. For instance here. Why doesn't that just factor? Well, it doesn't. Doesn't have the right numbers to factor. Not everything factors, right? It's the same idea. Not everything factors by grouping. Sometimes they do, sometimes they don't. All right, so if you think it'll factor by grouping, go ahead, do it. You'll impress me because I don't think this one factors by grouping. All right, so how else can you factor it? Well, using long division or synthetic division. So I'm just trying to show you why we need this thing for today. Because on a typical really hard problem on your test, we don't tell you what that magical number would be that would go with your synthetic. Like, you know that the 4 came from here, and the 2 came from here, and the 1 came from there, and the 7 came from there, right? But where the heck do you get this number from? That's what I'm going to show you today, is how to figure out what that number could be. Now, would you agree that it is probably some whole number, but there's a lot of choices out there? Like it could be 1, although that's the dumbest thing to put here, because it's like saying factor by 1. Won't any number factor a 1 out of it? Yes. So this kind of doesn't do anything. So don't you ever use a 1. But if it's not a 1, then maybe use 2 or 3 or 5 or which one is it? All right, it'd be kind of like this. Let's say that you knew that the kid who hit you in the parking lot was a girl because of you just had this accident in the parking lot, and then all of a sudden they drove away, and you didn't get their license number, which you really should get. If you ever have an accident, take a picture of the license number, like right away, okay? Because then later you can look up who it was that hit you, and then they're like, "Well, it's your fault, but I'm leaving," and then poof, they're gone. Okay, well, if you just knew it was a girl, do you get that would narrow it down very much? There's a lot. No, not right now. I'm busy teaching. Okay, so if instead you could narrow it down to like 4 girls, then you could go one by one and figure out, was it this one? Was it this one? Was it this one? Was it this one? Okay, so we can narrow this down to a few choices. That would be really, really handy. And then we could try them. Like if I told you, I know it's either 1 or 2 or 7, and it was plus or minus each of those, typically that's what happens, is you get it down to like 6 things that it could be that go right here. All right, so we need to narrow it down, get it down to a manageable number. Because if I told you it was a 1, you can use a 1. I'm just saying the dumb part about using a 1 is that 1 is a factor of everything. Okay, so therefore it's almost every time you're going to have a 1 here. It's more interesting when you find out whether it's like 2 or 7 or some other number besides 1. But if 1 goes there, you can try it. You can do synthetic and see if it works. All right, now, we need to do a couple things first. We need to review and make sure you know how to do synthetic and you know how to do long. So we're going to do one review of long division that's on your test. And then one review of synthetic, which will be just like it. Would you please do this with long division first? Then we'll do it with synthetic division, and it's got a missing term, which just one little extra step. You put a 0 in there for a placeholder term. Okay, so solve it with long division, then we'll solve it with synthetic, and then we'll talk about how do you know what goes into it? All right, if you know the placeholder thing, you'd have it by now. So let's see, Dice of Destiny. Who should I call on? It's row 4, person 2 today. That is Fiona. Good. So I'm going to rewrite it and say x plus 2 and then x squared, and you said put it in the middle, so I should put it next. What do I put right there? Plus 0x. Very good. And then you put the end of it minus 4. Perfect. You've got your placeholder in. Next. Row 2, person 1. Maddie, that's you. What do you do to solve this thing? What do you start with? An x at the top. Then the x times the x makes x squared, and I know that worked because those matched perfectly. This and this are the same thing. And then you go this times this is 2x. Draw the line, and here's where a lot of people forget opposite, opposite. That makes it negative 2x. If you had positive 2x, you forgot to make everything the opposite with this blue marks here like that. Okay, now, next person is row 5, person 3. She's gone. Keeps on going back to you. Isa. So what goes up here next? Negative 2. Negative 2 times the x. Oh, wait, can I bring this down? Negative 2 times the x makes negative 2x. It matched perfectly. That's how you know you did it right. And then negative 2 times the 2 makes negative 4. Draw the line. Opposite, opposite. And I get 0 remainder, so I know it worked. So if the question was that a factor? What's the answer? Yes, because there's... Yes, because why? There's no remainder. Okay, good. And then you would be able to write the final answer as x plus 2 and x minus 2. Now, a quick reminder of how the synthetic would have looked. Negative 2 goes here. Remember that deal? 1, 0, and negative 4 go there. They're the numbers that came from right here. 1 here, 0 from there, negative 4 from there. Now see if you can do the synthetic. Believe me, you're going to want to do synthetic. I know, I told you yesterday you could get along with just long division, but on a typical problem, you have to test 6 roots to figure out which one actually works. You're going to want the fast way. Drop this, multiply. It's always add, multiply, add, multiply, add, multiply. Actually, first it's multiply, so multiply, then add, multiply, then add. Although in a way, this is adding 0, so it's add, and then multiply. And then add, and then multiply. And then add, and you get 0. Yay, and that's the remainder. This comes down. X plus 2. Remember, that's the 0, or the solution. And this is the factor that goes with that. And this here is minus 2. I always just bring that one down straight down first, and then I remember that one's got the x on it. X minus 2, x plus 2. You might be like, but we already had that. Yes, because it's factoring. It's just faster. Okay, so now you have reviewed how to do synthetic. Let's just do one more with just synthetic, and it should go fast, like boom, boom. X to the third minus 3x squared plus 4x minus 12, and that's being long divided by x plus, wait a minute, let me think. Nope, x minus 3. Now, I set it up for long, but you should change that to synthetic because it'll be so much faster. Do synthetic and see, was that really a factor? If you get a 0 remainder, it was a factor. And then you can factor it. Vaughn, what's the first step? Setting up all the numbers. So what goes in the little box here?
3,
Positive 3. And then what are the numbers that go across from left to right?
1, -3, 4, -12.
Awesome. Did you even look to see if there was any placeholders? Did you think about that?
Kind of.
Okay, you should. This went 3, 2, 1. It was good. There was no missing, there was no gaps. But if there had been, and you hadn't noticed, it would have messed you up. So you always look and see, do I need any placeholders? All right, in the immortal words of Snoop Dogg, drop it like it's hot. And then I multiply. And then I add. And then I multiply. And then I add. And then I multiply. And if it comes out to a 0, you can bet that the probability of that being a mistake, like you somehow screwed up and yet got 0, almost impossible. Extremely likely if you get 0 that you did it right. And now can you interpret it? I can. Brady, what's that 3 mean?
So it would start off with x minus 3.
Correct. And which of these 3 numbers should I drop in first?
I would say you drop the 4 first.
I agree, because it doesn't have any x. And then,
Well, you don't really have to do anything with the 0.
okay, it would be 0 x's though, right?
Yeah.
And then what's the first one?
So then it would just be x squared.
X squared, you are correct. X squared. And that 4 is positive, right? Now the reason I asked is because if that was negative, we'd be able to factor it again. X squared minus 4 would have factored again. But in this case, it didn't. So, any questions? We just factored something that was kind of hard with synthetic. You with me? See how that worked? But what if I don't tell you this number? I'll show you on this problem how we could have known what the possible things are that we can check. And again, using my analogy of a kid hit you in the parking lot, you know it's a girl, way too vague. You know it's one of these 4 girls, then you could probably check those 4 and look at their pictures and go, okay, it wasn't her, oh, it's her. All right, that's what they do for like a lineup. I mean, we want to get it down to a small number of possible roots. So here's what you do. This time you can just pay attention. In a minute, you want to write the definition for this rational root theorem. Here's how you decide. It's based on the factors of the last number. That last number is called the constant. Do you agree that 12 has lots of factors? So we would probably never give you this one on the test because it's got so many factors. There's so many possible things that could have been roots of this. Like, doesn't 12 times 1 make 12? That's one set of factors, so it could be 12 or it could be 1. Doesn't 6 times 2 make 12? Yup, so 6 and 2 are possibilities. And then it's 4 and 3 can also make a 12. So all of these 6 numbers are critical to deciding what could have been it. What was it? It was actually 3. That's one of those numbers, isn't it? All right. But if you had checked 12, wouldn't have worked. If you had checked 1, wouldn't have worked. If you checked 6, wouldn't have worked. You know what I mean? Like, it's a pain in the butt to check all these things, but you check them with synthetic, and then they go pretty quick. All right. I want to do one that's overly simple right now on purpose to show you this process. And I know this is such a simple problem, you could have done it another way. X squared plus 3x minus 4. Now, I think we all know you could factor that without having to do any complicated thing. But let's use this little thing I just taught you and say, what are the possible things for synthetic, the zeros, that could go here? Well, you take the factors of 4, which is 4 times 1, and 2 times 2. And so 4 or 2 or 1 are possibly things that go here. Could it be 4? Could it be 2? Could it be 1? Yeah, it could be any of them. I don't know which one it is. And it gets worse. It could be the positive or the negative of all of those. That is 8 possible things. Oh, wait, nope. That's identical as the other one, right? So that's 6 possible things. But wait, it gets worse. Because if the number in the front of it, called the lead coefficient, if that one has multiple factors, you have to divide by those. Well, wait a minute. This number right here, how many factors do we have? Just 1. And do you get if you divide by 1, it doesn't really even do anything to it? Do you know what I mean? Like if I take all of these and divide by 1, it doesn't change them, does it? Okay, so in this case, those are our possible roots. It's either plus or minus 4, or it's plus or minus 1, or it's plus or minus 2. Can anybody, by thinking about what these factor to, can you tell me what it actually could have been? There's actually 2 that would have worked. Well, let's just take a second and factor it. Everybody factor this. Just use the old way. Old school factoring. Would you agree it would have been x plus 4 and x minus 1? Right? So what were the 2 winners? Out of those 1, 2, 3, 4, 5, 6 possible things, 2 of them would have worked. X equals negative 4 would have been a winner. And x equals 1 would have been a winner. All right, so let's just prove it. Everybody put negative 4 and then bring down these numbers and do synthetic on it. I know you'd never do that on this problem. It's too easy to factor in your head, but do you want me to start with a gigantic one? No, let's start with a nice easy. 1, 3, negative 4, draw the line. Drop it like it's hot, multiply, add, multiply. Cool, it worked. That's my remainder. You get a remainder of 0, you can pretty much know you were right. X plus 4, x minus 1. Does that make sense to you? You could have factored that way easier, a different way, but I'm just showing you how you could factor a typical test question. All right, now we're for the notes, and I think that they're going to go fairly easy. On this page, it says find the possible roots of this equation. That one has 3 factors, 1, 2, and 4. This one has 2 factors, 1 and negative 1. You take these guys' factors and you divide them by these. See how that goes on the bottom? You get final answers. It could be these 3 things. How do you know which one's right? You don't until you try it with synthetic. But let me show you, if you're good at this, how fast that can be. I'm going to test 1. 1. And then I put in these numbers. 1, negative 4, 1, negative 4. I draw the line, drop it like it's hot, multiply, add, multiply, add, multiply. Did they cancel out and make a 0 at the end? Nope. So it wasn't 1. Then if I want to save some time, I can just go right here and try negative 1. And just leave the same numbers. And now try negative 1 and see if that worked. You'll get really fast as synthetic. I can look right there and go 6 times -1 is not -4. Didn't work. So it wasn't 1 or -1. Now I try another one. Was it 2? Drop it like it's hot. Multiply. Add. Multiply. Add. Multiply. Oh, that didn't work. So it wasn't 2. See how fast I'm able to check them with synthetic? Has anybody found it yet? All right. Now, let's go on to the next one. I think you've got the big picture idea. Now, what are the possible real roots for this? Now, I disagree with how the notes did it. Not that they were wrong, but I think there's a faster way. I would list all of these factors first. So everybody go ahead and do that. Would you agree 12 and 1 is one set of factors? And the notes, they always put them in numerical order. I find that that doesn't make as much sense to me as finding combos that work, like 3 times 4 makes 12, and 6 times 2 makes 12. Now, if you want to go back and put them in numerical order, you can, but those are all of the things that make 12. And it's plus and minus of all of them. Pain in the butt, but true. Divided by the factors of the first number. Well, what are the factors of 1? It's easy to forget plus and minus 1. Now, just keep the plus and minus on everything. Don't get overly concerned with, did I do -12 divided by -1? Don't worry about that. Just keep plus and minus on all your answers. What's 12 divided by 1? 12. Well, aren't I just going to get the same thing as I had each time? Yup. Because do you get dividing by plus and minus 1 doesn't really do anything when you divide by 1? So then there's your list. There is your list of possible factors. Why would we never have this on the test? Because kids would literally have to check these two things, you know, plus and minus. These two, these two, these two, these two, and these two. 1, 2, 3, 4, 5, 6 things you'd have to check. Times 2 is 12. 12 possibilities, and you got to do rational root on all of them. Brrr, and finally you get lucky and one of them works. If you're really unlucky, the time that you were doing that number that was supposed to work, if you make a little mistake in it, then you'll think it didn't work, and you'll skip over it and go to all the others. This test runs long because a lot of kids are like busy checking 5,000 things to see which one of these rational roots could be the right answer. All right, let's do this next one. Would you agree that 5 and 1 are my factors of 5? There's no other factors of 5 that I can think of. So put plus and minus 5, plus and minus 1 over the factors of this, which are 2 times 1. So it's plus and minus 2, plus and minus 1. This is the first time where you have actually had to divide. What's 5 over 2? Well, it's 5 over 2. That's your first possible root. Fractions? Yep. And it's plus and minus that. Then you take 1 divided by the 2. 1/2 is a possible root. Yes, it is. Plus and minus 1/2. And then take the 5 divided by the 1, which of course is just a 5. And plus and minus that. And last but not least, 1 divided by 1, which is just 1. And plus and minus that. If it makes you feel any better, that is the last thing. From this moment until Friday's test, all I'm going to do is review with you. There's nothing new. Just this one last thing that we just taught you. All right? Factors of 10. Hakan, give me a combo that multiplies to 10.
5 and 2.
5 and 2 need to be on our list. These can be in any order you want. Vaughn, give me another combo that makes 10.
10 and 1.
Plus and minus 10, plus and minus 1. Is there any other combos that make 10? Nope. Then the 3. What are the factors of 3? Just 1? Oh, no, it's 1 and 3. 1 times 3 makes 3, right? So those are the 2 factors. And then the pain in the butt part really is just dividing them all. So I'm going to divide them all by 1 means I get 5 and 2 and 10 and 1, because dividing them by 1 doesn't really do anything. Now I got to divide them all by 3. 5 thirds, 2 thirds, 10 thirds, and 1 third. And it's plus and minus of all of those. Holy crap. That would never be on your test. Too many things to check. Do you get how I got them? I took all of them and just divided by 1, because dividing by 1 doesn't change them. And then I took all of them and divided by 3, see? And it's plus and minus of all of those things. Now, one thing I will allow you to do to save time is put plus and minus in a parenthesis like that. Do you get how that keeps you from having to write plus and minus like 17 times? If you want to put plus and minus in the front of it, I'm good with that. Okay. So let's say we did rational root and we came up with these are our possibilities. Do you get their 6 things to check? This is kind of nice because the teacher actually wrote out all 6 things. And they correctly put out the coefficients set it all up for you. So just take a second, test it. Let's see how long it takes you to find it. Drop it like it's hot. No, if you already got it, that's awesome, but you couldn't have got it that fast you must start it early. Oh, it's a question. Go ahead.
Can I go to the bathroom?
After you finish testing these, should take you a few seconds. Then show me a approved hub pass, and I'll say yes. Well, it wasn't 1, I'll tell you that. Did you find it? Which one was it? She says 4 works. Everybody, you have my permission to skip to number 4, but verify number 4 works. Yup, pretty sure it worked. Got a 0 remainder, but then can you translate this? Get it back to having variables. You know, like what is the answer? We factored it, and they got these weird random 41010. Mr. Long, do you know how to do it?
I think so.
Do it.
So, well, first side would be x minus 4.
Correct.
And then the other side, you would start off, I think you want to start from the right and have 1.
I agree.
And then you can skip over the 0 x
Yep.
part, and it'll just be x squared.
You got it. And since this one doesn't have a sign, we can assume it's positive, and there it is. How many of you had that before I said it? Okay, cool. Do you get what we're doing here? Now we don't even have to have them tell us what goes in it. You can figure out what goes in it and test them all. All right. So, this is just a reminder of how these get written out at the end. You know, this is the constant. This is the 0x part. I like to put it like right here and say that's 0 x's and this is 1x squared. Right. So, It's good to like talk about how you do them, but let's have you do one. You don't know what to test until you do the rational root. Then you'll know which ones could work, and then you'll test it. And if you end with a 0, you won. So you take the factors of this and you go 6 times 1 and 2 times 3. And those are all plus and minus. Don't forget that it's plus and minus. Then you divide them by, oh, well, there's just a 1 there. Do you really have to divide by 1? No. Dividing by 1 doesn't even do anything. So there's your list. You're going to check 6 and negative 6, 1, negative 1, 2, negative 2, and 3 and negative 3. This time, don't tell anybody what the final answer is. I want you to check several of them yourself before you finally get lucky. And a few of you will find it before the others. That's okay. So I'm testing 6 first. You start to see some of them get crazy. I'd, at that point, go, okay, 6 can't be it. The number's getting so big, there's no way that that's going to be a 0 at the end. So it's not 6, everybody. Did anybody also get that 1 did not work? Anybody verify that 1 didn't work? Okay, good. So it's not 6 and it's not 1. Who has found one that has worked? Don't say it, but ooh, a bunch of you. Carter. There's 2 Carters. Carter Johnson. What number do you think worked?
-2.
Everybody try -2 and verify he's either right or he's not. That's a really critical part. The second to the last one, because then on the last one you'll be able to go, oh yeah, it's coming out to +6. And that adds up to a 0. If there's a remainder of 0 right there, it worked. Congratulations, Mr. Johnson, you are correct. And your final answer would read x plus 2 and put the -3 at the end. That's how many x's. That's how many x squareds. And that's how many x to the thirds. And if there's no sign, put plus in. Cool. But did you even think about whether that would factor? It does, and it factors by grouping, and you don't have to go back to this other way of doing it. You could just factor it by grouping. But watch for that. Most common mistake on the test is kid turns in the answer and it isn't factored all the way. Even though you did all that work to get to here, this would have factored by grouping, and you needed to. Otherwise, you'd lose the points. Yes?
We got +3.
Yeah, me too. I
Okay.
got +3.
Now let's think about that. That means that one of these two is x minus 3. You see what I mean? See, we already factored out this one, and it did work, but somebody else got 3. That means you could either do synthetic or you could know this must be an x minus 3 right here. And when you factor by grouping, you'll see that it is an x minus 3. It's the other root that worked. So sometimes there's 2 roots that work. I know that was a little intense. You might be a little scared about this coming test. I don't know, maybe you're not. Maybe you've like gotten an A on every test, and that's a lot of you, so. But just be aware that if you do all the practice between now and Friday, you'll do fine. If you slack between now and Friday, this one is hard, and you might get a B where you normally get an A, or you might get a C where you normally get an A. And considering this is the first of the new set of cumulative, it's gonna be a while before the cumulative happens. It'd be kinda nice to get a good score on Friday. All right, so let's go to your homework. And, oh wait, one more thing. Your homework is a Schoology quiz that I did not release yet, because I wanted to give you one question to see if you really understood this.
But there's already 2 Schoology quizzes.
Hold on just a second. No, there isn't. Refresh your iPad. That one.
Okay.
It's one question. Did you get it? Everybody go do that question right now.
It's not what's
What? Okay, hold on. Settings. Ah, dang it, you're right. Enable. One try. Resumable, yes. Question review, yes. See the right answer at the end, yes. Okay, now try it. This thing is called, I don't know, have you ever heard of an exit ticket? It's like at the end of the hour, it's my way of seeing, did you actually learn how to do this thing? It's a multiple choice, but there's lots of right answers. I will give you this, there's more than 4 right answers. As soon as we have half of the class that's done it correctly, I'll release the homework. I'm gonna make sure it's short enough. You know, I don't like long homework. Now, since this is just formative, I am okay with you talking to the kid next to you, unless they already have the answer. If they've already hit submit and they know the right answers, that'd be just cheating. If you guys want to compare before you turn it in, I'm okay with that.
I don't know. Well, it's because there's kind of 4. Wait. 2 3 times 2 is.
Let's go.
Okay, last thing that I noticed in the homework that I haven't even released yet, but I'm gonna in a second. It's only got 7 questions, which isn't too bad. But they give you problems like this, and they ask you for that leading coefficient thing again. The leading coefficient of this is not x to the third. What's the leading coefficient? Yes. X to the third is not called the leading coefficient. X to the third is called the leading what? Yes, the lead term would be x to the third. The lead coefficient is just the 1 in front of it. Next is the degree of this. It's just the biggest power. It's that power right there. Okay? How many of you got at least 5 out of 6 on the little quiz thingy that I just gave you? Awesome. Then, I feel like you're understanding this well enough. I'm about to release the other Schoology quiz, and that's all I have for the video for today.